Welcome to today's presentation, Applying Compliance Frameworks with InSpec on Azure Government. Let's go ahead and get started. Galen, why don't you kick us off by telling our audience what we'll be covering here today?
Thanks, Jamie. And so to go into that real quick, the idea here is we're going to get into why Azure Government and why Chef InSpec together really helps solve your compliance needs. So we're going to start off with some introductions, why Azure Government by Derek, and then we'll do some Chef InSpec stuff with me, and then we'll go into Q&A and get you into some resources. So to kick us off in introductions, I am Galen Emery. I am the Federal Customer Architect for Chef Software. I've been with Chef for almost 4 years now. I originally come from Seattle. I have a strong Windows background, and I really enjoy working in the federal space. And with that, I'm going to kick it off to Derek for his introduction and his section of the presentation.
Great. Thanks, Galen. My name is Derek Schwartz. I'm a Microsoft Technical Solutions Specialist. I've been with Microsoft for 14 years, most of that in the federal space, working with customers where compliance is always something that we have to help our customers through and maintain throughout the life of our products. So I'm excited to be talking about that today and how Azure for Government helps us get some of the way and how Chef InSpec can help us sort of make that last mile. So when looking at Azure for Government and where it differs from standard Azure, I'm going to assume that we have a solid understanding of Azure commercial and cloud environment. So what's different about Azure Government? The main premise behind Azure Government was to create something where we could achieve a higher level of accreditation. Our commercial cloud is FedRAMP Moderate and DISA Impact Level 2. Azure Government was designed to be FedRAMP High and DISA Impact Level 4, and we have a DoD DISA Impact Level 5 cloud as well. So one of the things was to make sure that it was a secure and compliant to meet those accreditations. One of that included operated by screened U.S. personnel. It had to be physically isolated. These are in their own buildings at our data centers, and they have their own separate cage space as well as network. We do have to have multiple links supporting geographic redundancy and failover, and the data has to stay on U.S. Soil. So looking at those, within the security and the compliance is where we're going to focus today. The privacy and controls, transparency with our trust center, as well as the reliability metrics and where we stand with SLAs are all available on the Azure Government commercial page. Azure Government today is in, we've upped this to 4 existing regions for the Impact Level 4 or Azure Government environment, those being in Virginia, Iowa, Arizona, and Texas. There are 2 DoD regions, East and West, and those are all online and running as of now. If you want to switch over, I'm going to switch to my screen here and show you the differences between the Azure Government and the Azure Commercial. There's a difference between the services that are offered at the different levels. If you look here, you can go to the regions and services pages, and it'll give you a breakdown based on all of the different things such as compute, networking, and you'll be able to see across the regions as well as commercial. If you want to just look at what's available, you can always go into the region selector, turn off United States and leave just Azure Government selected, and that'll give you a rundown of all of the capabilities within that cloud. This is constantly updating as new features are accredited and added. So make sure that you bookmark that and check that out to see what the newest capabilities are. Moving back into the compliance, right? So actually we'll cover the Express Route. If you're not familiar with Express Route, this is the ability to directly onboard into Microsoft's dark fiber network. Microsoft has one of the largest private networks in existence. It's in the top 3. And the way that we use that is for replicating data back and forth between data centers and maintaining the actual service itself. ExpressRoute allows for customers to onboard from their networks directly into that private network to keep latency down and to establish connectivity without having to route through the internet or use standard VPNs where there may not be good connectivity or high latency. Looking at the compliance, this is across all 4 or all 3 of the clouds, the commercial, the government, and the DoD. We're going to specifically look at these today, the US government ones and where they're relevant. And then we're going to talk a little bit about some of the capabilities. Our clouds are open. They provide for multiple different providers, multiple solutions to run on top of them and still maintain that accreditation through the underlying infrastructure being accredited. Chefs, we're going to talk today about how we can leverage the Chef capabilities to sort of go that last distance above the infrastructure and to take care of the actual application itself and how you can achieve ATOs with that. So looking at the cloud itself versus disconnected environments, it's important to know that a lot of those same capabilities are available in something called Azure Stack, where you have a on-premises version of the Azure code running, where you can, on hardware solutions from various providers such as HP and Dell, have an on-premises version of Azure running, so you can leverage some of that common identity, the integrated management, and unified DevOps, so that the stuff we talk about today to inspect your machines and look at compliance and make sure that they're where they need to be is reusable for both the on-premises solutions that you develop as well as the cloud solutions that you develop. And that's Azure Stack. You can look up some information on that as well. It's all out there on the Microsoft page. But specifically talking about compliance and how to meet those requirements, one of the things that we offer are Azure Blueprints. Azure Blueprints are a big part of how we help customers make the transition to the cloud and achieving those ATOs and meeting the accreditation requirements a little bit easier, right? When you step into the cloud, so much of the stack or the operating environment, storage, networking, compute, is sort of given this level of accreditation and it's inherited those controls. So what Azure Blueprint does is it sort of helps you get your hands on what the gaps are and what you as a customer would be responsible for within your application, where you need to apply certain controls, and then what's given to you and applied. The way that works is, I'm going to again share my screen out and show you. In this service trust area, right here at the servicetrustmicrosoft.com, we have all of our trust documentation and things like that. But if you look under guides, there's this Azure Blueprint program. And if we look at that, we can see that it provides us with a couple different documents, right? Some of these are Word docs, some of these are Excel spreadsheets. And you can see that some of them are the templates that you need to put that documentation together to achieve your accreditation. And then this spreadsheet here will give you the gaps that you are responsible for and show you what controls. So an example would be, here's the level for the environment, because they're specific to applications or the operating environment itself, right? And we'll give you the control IDs and a place to put those notes in. And then once we couple those with the actual control implementation guidance and template, which you can see is actually a rather large document, 551 pages, but this will get you through. Most of this is just formalities and forms, but it can get you to where you can see where the solution is that's being implemented, how you're meeting the requirements, and then couple that with the spreadsheet on where the gaps are, where the controls are. Now, obviously, hitting STIGs and making sure that things are compliant with a software configuration, et cetera, is incredibly important, right? Moving towards where the idea is that the platform itself, Azure for Government, combined with the blueprints and the controls, gets you to a certain point, and that would be the blue, depending on what sort of capabilities you're rolling out. But there's always remaining that specific gap to receive a system ATO. And that's the sort of things that become the customer's responsibility to manage and take care of. And so Galen is actually going to take over, and he's going to show you how Chef InSpec can help sort of give you the read on where you stand with some of those controls and then how to remediate those controls. So Galen, I'm going to throw it over to you.
Thanks, Derek. And let's go ahead and get started, or continue on more accurately. So as Derek mentioned and talked about, Azure and Azure Government gives you a lot of things on the back end, on the data center layer, to get you close to that ATO. The thing that we come in and deal with is start dealing with how do we manage these systems that we're going to put in on top of the ATO, on top of your Azure Government stack. So just a real quick about why this is important and why we need to start codifying these things rather than doing it manually is that digital transformation is taking over. 71% of IT orgs adopt DevOps. We're working fast. And what we want to do is really reduce the amount of slowness and really increase our velocity by automating our InfoSec and security protocols as we go through the process. And what we're finding is that the current state of information security is that most teams, most companies need either days, weeks, or months to remediate issues. And in the world of 0 days that we live in now, in the world of hardware 0 days and everything else, we need to have these things fixed faster than we have in the past. And so what we've had historically in the past is that if we want to fix those things, we have to slow down our rate of innovation, right? There's a curve between quality, compliance, and security, and the rate of innovation and the rate that you can go quickly. Us in the federal government and also in the financial sectors as well, we typically tend to go on the quality, compliance, security part of this arc. And your big web companies, your Ubers, your Lyfts, things like that, they're on the far bottom edge, the rate of innovation piece. And so what we really want to do is with Azure Government and with Chef InSpec, we really want to make sure people move this curve out. It's not just about moving along the curve, choosing where we want to be. It's really about pushing this further, doing more with less. And so the way to bridge this gap is that we want to use code-driven tools with fast feedback loops for all of our teams. And what we really want to do is get into this idea of compliance as code. Historically, our compliance and InfoSec teams have worked in a very reactive model. Auditors come in, we sit down with them for 2 weeks, maybe 2 months, whatever it is, and we go through line by line on our systems. We figure out what's wrong. We fix it for the audit. The audit passes, they walk out the door, and then it's forgotten about until 6 months or a year later when the auditors walk back in the door again and we go back to the same process. And this is very reactive. It's often done by hand. It's very short term. There's no proof that the system stays compliant through the process. And so what we want to transition to is this more proactive model. What we want to do is express the policy as testable code so we can run it regularly and help give us a more long-term process improvement. And the reason why InSpec exists and the reason why we think InSpec is the right tool for this is that InSpec bridges this gap. Right now, there's a gap between our compliance, security, and DevOps teams. Compliance teams often come in, if we're lucky, with Excel spreadsheets. Sometimes if we're very unlucky, it's a big binder that they have that they bring in, put it on the slam on the desk, and we go with. Our security and InfoSec teams often have scripts or other tooling to manage things, but it's very ad hoc. It's very individually driven. There's no good source code management. There's no good tooling around it. And then our DevOps and operations teams are using Chef and other automation to actually manage the infrastructure. And so what we want to do is if we can unify around this one language, if we can unify around InSpec, we can show everybody at the same time the things that they need to know to do their jobs. So what is InSpec? I've talked about it a little bit. InSpec is a continuous, is a compliance testing language. It's also an integration testing language. And the idea here is we want to translate our compliance controls into code. We want to express these as statements of policy. The idea here is we're going to move our risk from the runtime to the build and test environments. We're going to move it earlier in the process. We call this shifting the risk left in our pipeline. The idea is to find issues early. We can write the code quickly. We can run the code anywhere. And we can inspect machines, data, and APIs. So the basic idea here is we want to scan for compliance, build and test the fix locally, build and test it into the pipeline, remediate it, verify that the fix works in production. And so the idea here is that we want to bridge this gap. Security and operations should work together. We should no longer be involving InfoSec at the end of the process or kind of as we go, as we get into production or afterwards. And so with that being said, let's go ahead and show a bit of how this works and how we can make these things happen for ourselves. Don't forget that if you have any questions, feel free to put them in and we'll get to them as soon as we get to the Q&A. The more we have queued up, the faster that process is going to go for all of us. All right, so just checking to make sure my screen share is on. There it is. So what we have here is Chef Automate. Chef Automate is the product that Chef sells as a licensed product. We have a number of components within Chef Automate. We have this node view here, which shows the health of my systems from a chef cookbook standpoint. We'll get back to this in a little bit. But we can see here I have 4 nodes, and they are currently healthy from a check-in state. That is, when they run their policy, when they run their automation, they are coming back clean without any errors. However, if we go over to compliance, we'll see that we have some issues going on in our systems. So I have 6 total systems showing up here. It's because a couple systems are getting counted twice because I'm running profiles in a couple different ways. But what we have here is a health dashboard of the systems themselves. We can see here that the systems are trending red. That's not a good sign, but that's really just as I've added systems in over here. And we can see here in terms of where things are coming from, we've got some Red Hat systems and some Windows Server 2012 systems with some failures on both of those. So there's 2 ways I can look at this from a health standpoint. I can either click on the nodes view, or I can click on the profile view to look at either the node level view or at a profile level. I'm going to start off with the node view and kind of go through this real quick. I have in here a couple different systems that are running profiles, and we can see the last time the systems were scanned and then how many failures that were exhibited on that particular scan. So let's go ahead and start with the Red Hat 7 CIS profile here. And what we have here is the results from this profile. This profile itself has 189 total controls. We passed 120 of them. There are 5 minor controls that failed and 64 critical controls that failed. If I go click here, I can see the minor controls that have failed. I can kind of filter by whichever piece I want here, pass controls as well. So this profile that we have here, where do we get it? How do we build it? Where does it come from? That's what we want to go talk about next. And what we have here is I have installed 5 profiles locally into my system here. I have 93 total profiles available. These 93 profiles ship out of the box with Chef Automate. You'll see here we got CIS for AIX, for Amazon Linux, for Tomcat, for OS X, CentOS, Oracle, Solaris, Red Hat, Ubuntu, Windows, you name it. And along down here at the bottom, we have some other ones here. We have some of our DevSec pieces for MySQL, Nginx, SSH, things like that. And we have the Red Hat 6 STIG profile. So I'm going to go ahead and look at this Red Hat 6 STIG profile. And we have here 261 controls. And the question we have to work with is, how do I take what my security team has told me I need to follow, either STIG or CIS, and translate it into InSpec? And first off, with Automate, we do that for you as much as possible. But let's talk about that process of what we would go through. Over here, I have the DISA SCAP content page open. I can see here, I'm gonna go ahead and make this a little bit bigger for everybody. I can see here all the various profiles that DISA releases that has the SCAP content with it. Inside of this, there is a Red Hat 6 STIG benchmark. That's this file right here. I've already downloaded it and extracted it, so let's go ahead and take a look at what shows up in there. In here, there's 4 different files. Here's some definition files. But what I really care about is looking at the OVAL and XCCDF files. Expand that out so you can see the full file path on them real quick. So these 2 files is what DISA uses to define what should be happening on your system, what shouldn't be happening on your system. So if we want to take one of these particular controls, say for instance, I have open here right now, the Exinet D service should be disabled if possible. This is the description in the OVAL file. This tells us kind of what we want to do, what the criteria is. You know, the comment service Exinet D is not configured to start. We have another one here, Exinet D removed. So if I want to go figure out how DISA wants me to do this, I have to take this reference ID, re-expand out my folder path here, come over here, and then I have it open right here. So here's the actual piece right here. Here's the actual check in the XCCDF. Here's the description. We have some reference information here. We have some more system information. And here's the fixnet text, which is fixed text, which is say, hey, you want to install it with this command, yum erase Exinet D. Okay, that's pretty convoluted to deal with, but we can go through that and we can translate it. However, Chef has done that. So let's go ahead and come over here. We'll go look at this profile. We're going to search for Exinet D. I have to remember to not get ahead of my screen share. Let's go ahead and look at the first one. Here, Exinet D service must be disabled if no network services utilizing it are enabled. If you click this control, again, this is in the profile itself, I can see a number of things in here already. I can see a number of tags defined, some references, things like that. I can actually look at the exact code that this profile has inside of it. And this is where InSpec gets really powerful. Not only do I have the check itself for what we're looking for, but I have all the context I need to understand this profile also here as well. So a couple of components here in the profile that are really important. First thing is this impact score. Impact score is rated from 0 to 1, 0 being minor, 0 being minor, 1 being critical. This is done from the NIST guidelines in terms of how you rate impact security scores on things like this. We have a title here, which is a nice friendly human title that tells us what this thing is going to do. We have a little longer description, which is saying, hey, this is what this listener service is. It's no longer necessary for commonly used network services. Disabling ensures that these uncommon services aren't running and prevents attacks against ZynetD itself. We can tag this with a number of things, a number of pieces of metadata to enable better searching and better readability and usability in your environment. So in this case, this is a Cat 2 severity rule from STIG. You can see, again, that these check IDs and things show up here as well. The fixed text is what this says, hey, this is how you run it, how you disable it, check config, ZynetD, stop, and then here's the check content. So it gives some more content from DISA. And then again, a tag out to the remediation where we link it out to a zip file of what's going on. Down here at the bottom, this is the entirety of the actual check itself. And this is where InSpec gets particularly powerful again. We have a service resource in InSpec that understands how to look at services depending upon the operating system it's on. We define the service itself, and we say it shouldn't be enabled. And then we say it shouldn't be running. And when we go to run this on our systems, we're going to find out whether or not this passes or fails on our particular systems. All right, so moving on from STIG, let's go ahead and take a look at the Windows 2012 R2 STIG. We're not going to move away from STIG. We're going to go back to Windows here and show that this works on not just Red Hat, but Windows systems as well. Let's go look for one here. See here, minimum password age must meet requirements. If I come in here and look at this, I can look at this thing here and see what's going on. So again, looking at the code, we have a control title here. We have a title. We have a description. We have an impact score. This one's improperly configured at 10. It's going to come in as critical as a 1. And we have the description as we go through here. Right here, we have described security policy. If you're familiar with managing Windows systems, you'll know the security policy gets stored in a couple different places. Sometimes it's a registry key, sometimes it's elsewhere. And so what we have done here is that InSpec, again, is abstracting away some of the information away from you. You don't have to know where that security policy registry key is. InSpec knows that already. And so again, looking at here, minimum password age should be greater than or equal to 1. Again, very straightforward in the actual check itself. One more that I really want to show before we kind of move on and start to wrap this up is if we go into, I'm going to go into one of my smaller profiles just because they're easier to work with. Let's go with the Linux security baseline. And let's go with, let's actually go back one more. Sorry, I want to go to the SSH baseline. SSH is a pretty standard misconfigured piece of tech, and there's some things we can do to make things really nice and easy. So on the client side, specify protocol version 2. There's actually also the server side version of this as well. And again, this is pretty straightforward. This check, by the way, exists inside of the CIS and Red Hat, or in the DISA STIG profiles, of course, because of course we should not be using SSH protocol 1. But this is pretty straightforward. And the thing I like about this, particularly with Linux-based file systems, or Linux-based systems, which are file system based, the SSH config, we know where to find that, and we know how to parse it. So previously, when you'd run this type of thing, you'd do a bunch of regex to go look through for protocol, and the next thing after it should be 2. Instead, we can just say, hey, I know that this file is a key value pair file. It's a config file. It's straightforward. I know how to parse key value pairs, and so I'm going to say the protocol should equal 2. And that's it. So we have these profiles here. Like I said before, we have a number of profiles already existing inside of Chef Automate. The way it works is when you take a profile from here, let's grab the AIX one, just because, you know, will be fun. And we'll go ahead and say git. What this does is it takes it from the internal store on the Chef Automate server. It's not downloading it from anywhere, and then it's installing it locally into your user space so that you have access to this profile. So we've talked about the profiles. I can install the profiles. I can work with it. There's two more components I want to cover real quick. One is, how do I go run these on my systems? And then as well, how do I make modifications to this, or how do I change this based upon the information that I have to work with? So if I come here to reporting, I can see these nodes. I can see these profiles again. Let's go ahead and click on this node. Let's go with this one, CIS Red Hat 7. We saw this one before, but how did this thing run? So we're going to go back over into the Nodes tab. We're going to come over here to the CIS Red Hat 7 node, and we're going to look at the resources that it follows on this particular run. And we can see it's got a number of things in here. This is just to set up Chef Client to run, but there's this little audit cookbook here at the bottom that's not doing a whole lot. But let's go ahead and check out some information around it off of Chef. Actually, let's see if we can't get to it from Automate. So if I go to the run list, I can see that I'm running the CIS role, and inside of that is the Azure-based cookbook. If I come in here to attributes, I can actually see what's being defined in the audit cookbook. And this is what's going to tell us what to run and from where. So all this information here is being sent from the node to the Chef server, and therefore the Chef Automate server as what's going on. And so what's happening here is I'm running this particular profile from my Automate server with this name. And what happens is every time that Chef client runs on this box, so every time that your DevOps teams or your operations teams make changes to the system, or the system gets changed via the automation, we're going to go rerun that compliance profile and see if we follow or don't follow our particular rules. So that's one way we can run it, is we run it through the audit cookbook that we attach to the Chef client. We can also run this against systems that don't have Chef installed. And so what we have here is, this is a feature that's in beta right now, but it's accessible to anybody with Automate, is the scanner feature. And there's two components to this. One is the credential store, where you define your credentials for SSH or WinRM connections to your systems. And then from here is the scanner, where we create a job off of these systems. So if we give this one, Azure Webinar, I can select the systems I want to run against. In this case, I'm going to go run against my Red Hat 7 system. I can set it on a schedule. I can repeat it every day, minute, hour, week, or month, or I can tell it to end on a particular time as well. In this one, we're just going to go ahead and run it once. So Red Hat 7, I'm going to just go run the Red Hat 7 server, this particular profile here, and I'm going to go ahead and create the job. Go ahead and refresh this page. We're starting to see a bunch of things in here. I've configured some jobs from before. And so this job right now here is running. If I come back here and I can see that these particular jobs are set up to run on a schedule. So this CIS Win 2012 is completed 6 minutes ago. I can see in this particular case, I've got two systems, my two Windows systems with one profile. Previously, I looked at the view of issues based on a node having issues. I can also look at it per profile, and I can click here on scan results on any particular issue and see all the nodes that failed that particular check. And again, I can dive down into the actual check itself. The value here is that sometimes I want to know what systems are failing based on the profile. Sometimes I want to know what profiles are failing per system. So I can slice this data either way, whichever one makes the most sense for me. Coming back here into the scanner, this one's already completed. And again, we're not going to see anything particularly surprising. We're going to see that this one system has failed as we haven't made any changes to the box itself. The last thing I want to show real quick is the idea of, and let me go ahead and make this bigger. I forgot to do that earlier. Is what if I want to work with a profile that is, or I need to remove some of these things, or I need to add some other things to these profiles. We all know that we don't follow the CIS or the STIG rules to 100%. Doing so gives you a completely useless brick of a system. So there's always exceptions we have to file as we go through this process. And so what we can do here is we can create a wrapper around this piece. So I'm going to go ahead and create a profile called STIG wrapper. This will do is allow me to wrap around my STIG profile. If I come over here back into this view here, let's go ahead and clean this up a little bit. I can come in here. I can see the STIG wrapper. So the things you in a inspec file that you are inspec profile that you are creating locally is a couple things. You need this inspec YAML. This is the file that tells inspec kind of what to do, who owns it, pieces like that. And you also need to define any controls you have here. We give you by default some examples. Again, you can look here, the file resource, looking at /temp. It should be a directory. When you define these controls, you can define them with or without an impact. If you don't define an impact, it'll come in at a 0.5. So I actually already have a CIS wrapper one here. Go ahead and create it. And we're just going to look at this real quick because this is an interesting situation here. The way it works is, actually, let's start with the inspec YAML. The way it works is this. You define in your inspec YAML any dependencies on profiles that you have. So in this case, and we define the name of it. So in this case, it's the CIS Red Hat 7 level 1. I'm going to go ahead and define my local path to what to where I've stored a copy of that profile. And then in here, I can include controls from that profile, and I can do a number of things. In particular, what I was working on before for a different piece is skipping all of my failing controls to see if I can't get a pass on this particular thing. But we can also do things like include controls. One, two, let's go and create that. Oops. And let's go ahead and go back into this piece here. Let's find one of these that's critical. So let's find one of these that's minor, and we're going to change its impact. So go ahead and look at the source of this. Sure, RDS is disabled. I can see this thing is set as an impact score of 0.0. Sometimes when you're working these things, you're actually going to find that you're going to find that the impact score that's already defined is not something that you agree with. And so we can do things like this. We can modify the impact. I could modify the actual check itself. I can really modify anything I want around this control. And the last thing that we would do here is we'd come back over here. And what we would do is an inspec upload of this particular profile. Because this is large, it's going to take a little bit. I'm not going to wait for it. But we're going to go ahead and start kind of wrapping things up. So we'll go ahead and end the screen share. And so just to kind of wrap up what we've been talking about a little bit, we have a number of profiles already defined in Automate. We have the CIS profiles for CentOS, for Windows, for Ubuntu, for Red Hat, for SUSE, AIX, etc. There's a number of different profiles there. And then the idea here is this kind of what we like to call detect and correct. So you detect what's going on with the inspec, and then you fix it with Chef, and that's going to help you get that full system security as we go along. Another question we often get asked is kind of where does inspec fit in the tooling around security? We're really just a part of the tool chain. We're not a replacement for intrusion detection systems or intrusion prevention systems. We really work as a conjunction with it. The idea here is that we are looking at, from on the system itself, we are checking the system state. And with that being said, it's time for questions.
Thank you so much, Galen and Derek. We are going to go ahead and take some questions. And let's go ahead and just start at the top here. Folks, go ahead and submit questions as you think of them. We've got plenty of time here. Our first question is, once I scan my systems with InSpec, how do I fix them? Galen, are you still there?
Am I back?
You're back. Thank you.
All right. Yep. Sorry. Yeah, so when you scan your system with InSpec, how do you fix them? The answer to that is with Chef. We often get asked the question along with this is is there an auto remediation? And the reason why we don't give out auto remediation stuff is primarily around the fact that the view around Chef and around infrastructure management and desired state is that you should really understand the intended and desired state of your system and not to just automatically fix things just because you found them. More often than not, the things that you find that are security issues are actually going to be very critical as a result of the way your applications or your systems are configured, and you'll have other exceptions to file or other ways to solve those particular problems. So the idea here is you scan it with InSpec. This gives you the information you need on what you need to go forward, either fixing or modifying your controls to make sure that you have the correct security system configuration for your particular environment.
Excellent. Okay, our next question is, I see CIS profiles. Where are the DISA STIGs?
Yeah, so the actual, to give you a little bit of inside baseball in terms of how Chef creates these profiles, we actually translate them from the SCAP tools, the SCAP profiles that are provided by CIS and by DISA. The CIS ones were easier to translate than the DISA ones, so they're the ones who went in first. We are currently spinning up teams to continue translating the DISA ones. As you saw today, there's the Red Hat 6 STIG is in here. We are working on the Windows 2012 R2 STIG. I have a version of that in this view as well that has not yet been released to automate customers.
Okay, thanks, Galen. Derek, I've got a question for you. Is there a way to get our Active Directory accounts in Azure?
Yeah, so just like with Azure Commercial, we have a feature called AD Connect that allows an organization to link their existing Active Directory and replicate all of those into the Azure Government Azure Active Directory. Now, this helps for people who want to use that as the control for logging in and setting granular level permissions inside the framework of what can be created, like virtual machines and things like that. But it's also good for pass-through authentications, things like that. And if you happen to have two-factor or smart card or cat card authentications, you can actually do federation through that same AD Connect and allow the local Active Directory to be the entity that actually authenticates and approves that user. So it's more like a reference. You would hit the Active Directory in Azure, that gets pushed down to the local Active Directory where your CAT card could then be authenticated and let them in that way. So there's quite a few options to tie in Active Directory accounts.
Wonderful. Thanks, Derek. Galen, can you tell us what systems and devices can InSpec scan?
Yeah, absolutely. So InSpec, as I showed today, was scanning Red Hat and Windows systems. We support every major operating system out there. So Red Hat, Windows, AIX, Ubuntu, you name it, InSpec can scan it. We also can scan Docker containers, and we are currently working on both network devices and firewall devices, and along with clouds like Azure.
Okay, thanks. Derek, how can I connect without having any public IP addresses, only organization traffic?
That's a good question. So the express route is typically the way that we see people connecting, but it's important to understand that you can also leverage VPN gateways. And if you don't care about latency, you have a real high-speed connection to the internet. Again, the VPN connection is going to encrypt that, and it's going to allow you to talk to your internal Azure Government virtual networks the same way that you would if it was a remote site and you wanted to set up firewalls between the two to tunnel the traffic. That way you can stay within your IP address range, both the on-premises one and the Azure virtual networks, right? This means that you don't have to create that public IP resource that allows normal internet traffic to come in. Along those lines, you can also create DMZs or leverage network security groups to control traffic flow so that you could create, a network with your web servers in one side and your internal database systems on the other side. Maybe put public IPs on those web servers, but then make sure that the web servers can only talk through a virtual firewall appliance or something like that to the on-premises resources or data repositories, right? So this is allowing you to sort of shape that data for either all private communications or allow a public IP address on maybe one or two web machines, be it load balancers or something, to control that traffic flow in, just like you would your conventional networks.
Excellent. All right. Can anyone working with a government agency get an Azure for Government account?
So that's one where you specifically have to look at which environment. So if you're looking at Azure for Government or just impact level 4, then people who are providing services to the government, contractors, things like that, have the ability to create, as long as they're sponsored and vetted. There's a sponsorship approval process, if you will, to ensure that the work is being done specifically for a government agency and that there's controls in place. For the DISA Impact Level 5 or the DoD environment, that is only available to DoD entities. If they need to create a account for a partner or for a solutions provider or consultant, they have to create that within their own environment, going back to that Active Directory, right? They could have an Active Directory account for that person and replicate it up to the Azure Government DoD Active Directory, but they originated that account and they're responsible for holding and vetting that personnel. The company or the provider can't directly get their own Azure subscription in DoD. That has to be through a DoD entity.
Okay, thanks for that. It looks like we've gotten through much of our questions here. Derek, you want to add any closing remarks and share some resources and next steps for our audience?
Yeah, absolutely. So going through, we talked about the regions and the services. So it's important to understand that all three of the clouds that I spoke about today, both the commercial side, the Azure for Government Impact Level 4 or FedRAMP Moderate, FedRAMP High, and then the DoD Impact Level 5 FedRAMP High Cloud, all have their own capabilities and their own services. The Impact Level 2 and FedRAMP Moderate are the commercial, which is obviously going to be the first place where services are placed in. They're going to be worldwide. They're going to be available. If the data is not classified to a certain impact level, we always recommend using the lowest one available for cost reasons as well as availability of services. And then as we move up, right, there's a lag between service availability and what's available in the higher clouds, just because of the time it takes to get accreditation, to put the paperwork together, to get the sponsorship done, et cetera, et cetera. So the best way to know what's happening within each cloud is looking at that Azure Microsoft.com regions and services, which I showed you a little bit of, and then filtering based on specific features that you're looking for and understanding which clouds provide those. And then I left you some links here to the actual Azure Government website, which will give you all the information you need from a high level. The documentation site will dig into the details around each service and feature, how to do Azure CLI calls through Bash against the Azure Government versus the Azure Commercial for scripting purposes. And then there's the trial information right there if you want to get on board with a free trial, try it out, see what it's available. And then that last link there is the Azure Government Blueprints. So the easiest way is just to go to servicetrust.microsoft.com and then go into the services in the Azure Blueprints, as we showed. With those resources available, you should be able to get anything you need. And if you have any further questions, you're always able to contact your local Microsoft resources or contact the Microsoft sales group, and it'll get routed to one of us who can follow up and give you the information you need. Thank you.
Thank you, Derek. And Galen, any closing remarks?
Not a whole lot, but to echo what Derek said at the very end, if you would like to learn more about Chef Automate and InSpec and the compliance profiles and compliance capabilities of Chef to help you get that last mile to get that ATO, please reach out to Chef and we'll get you in touch with one of us.
All right, thank you so much. We'd like to thank our audience for your live participation today. As a reminder, a copy of today's slide deck and additional help materials are available in the resource list widget at the bottom of your screen. We encourage you to download the slide deck and bookmark any links that you may find useful. We, of course, hope you found value in the information that was presented today. If you like what you saw, we encourage you to share the recorded presentation with your teammates or professional networks. The on-demand version should be available by tomorrow, and we'll email you as soon as it's ready. Thanks again for your time, and have a wonderful day.